In this video, we are going to discuss about stack and related instructions in 8085 microprocessor. First of all, let's see what is stack. The stack is a set of memory locations specified by a programmer for use in a particular fashion. Data has to be stored in stack in LIFO basis, that is last in first out basis. The stack has a unique location known as stack top. The 16-bit register known as stack pointer hold address of stack top. Data bytes in a register pair can be stored on stack using push instruction, and it can be transferred from stack to respective register pair using pop instruction. At beginning of a program, stack pointer is initialized by programmer by using instruction LXI SP data 16. Once stack location is defined, storing of data bytes begin at memory address, that is one less than address in stack. Let's see the first instruction which is used in stack operation, that is push RP. Whenever this instruction is executed, content of register pair is moved into stack. Stack memory is declared by means of this instruction LXI SP data 16. As we know, RP represents higher order register in register pair. So this instruction may be push B, push D or push H. So let's see the sequence of operation taking place during the execution of, say, push D instruction. So when push instruction is executed, following things happen. First process is stack pointer is decremented by 1. SP become SP minus 1. Second process is content of higher order register is moved into SP. In this case, higher order register is D. D register content will move into SP minus 1. Then again stack pointer is decremented by 1. Now stack pointer is SP minus 2. Into that location, low order register content, that is E register content, is moved. So this is the operation taking place during execution of push D instruction. Here addressing mode is register indirect. When we are converting this instruction into machine code size is 1 byte long, so it is a 1 byte instruction. In order to complete the execution of this instruction, it requires a 3 machine cycle. As usual, first one is opcode fetch, then 2 memory write. Here we need to store the data which is available in registers into memory location. So 2 memory write operation is required. During first memory write, higher order content is saved into memory location. During second memory write, low order content is moved into memory. So 2 memory write and opcode fetch is required in order to complete the execution of this instruction. So total T state is 6 plus 3 plus 3, which is equal to 12. Here for opcode fetch, it requires 6 T state. Let's consider one example. Initially B contains 30 and C register contains 50, and stack pointer is pointing this location by means of the instruction LXI SP 2000. After execution of push B instruction, what is happening? Let's see. So B contains 30 and C contains 50. So this is SP stack pointer. Now whenever this instruction is executed, the first process is SP is decremented by 1. So 2000 minus 1, it becomes 1F. Into that location, higher order register content, that is 30, is transferred. Now SP is SP minus 1, which is 1FFF. Again, SP is decremented by 1. Now stack pointer is pointing this location 1FFE. Into that location, low order registers in register pair, that content is transferred. Now the data which is available in BC register pair is reached into stack. Now what is stack pointer? Stack pointer will point 1FFE. So this is the process which is happening during push B instruction. Let's consider another example. Here, before execution of this instruction, content of B and C was FD and 1A respectively, and stack pointer is pointing this location 2053. So top of the stack is 2053. So stack pointer denotes address of stack top, that is 2053. So it is clear that up to 2053, that is occupied stack. So from this location onwards, that is 2052 onwards, that is empty stack. So whenever this instruction is executed, stack pointer is decremented by 1. Now stack pointer become SP minus 1, that is 2052. Into that location, B register content will move, that is FD will move into 2052. Again stack pointer is decremented by 1. Into that location 1A is moved. Now up to 2051 the stack location is occupied. So 1 less than address in stack, that is from 2050 onwards the stack is empty stack. Next instruction associated with the stack operation is pop RP. Pop instruction transfer content of top two memory locations of stack into specified register pair. The format of this instruction is pop RP. It may be pop H, pop D or pop B. So whenever this instruction is executed, following sequence of data transfer will take place. The first operation is, whenever this instruction is executed, content of memory location pointed by SP, that is stack pointer, is transferred into low order registers in register pair. Then SP is incremented by 1. SP become SP plus 1. Then content of memory location pointed by SP is transferred into higher order register. That is, now SP is SP plus 1. That content is moved into higher order register in register pair. Then SP is again incremented by 1. Now totally when we are seeing, SP become SP plus 2. Let initially the B content be 30H and C content be 50H, and stack location 2000 contain 80H and 2001 contains 60H. So B content is like this, 30 and 50, and stack pointer is pointing the location 2000, and the content of 2000 is 80 and content of 2001 is 60. Now after execution of pop B instruction, whatever be the content of stack pointer is 2000. In that location what is available, 80, that is moved into C register, that is low order registers in register pair. Then stack pointer is incremented by 1. Now stack pointer become SP plus 1, that is 2001. So what is the content available in 2001? That is the content of SP plus 1, that will now move into B register. Now the stack content is reached into BC register pair. Again stack pointer is incremented by 1. Now stack is pointing the location 2002. So this is the operation which is taking place during execution of pop B instruction. Now SP become SP plus 2, that is 2002. Let's see another example in pop instruction. Here the example is pop D. So let's see that operation here. Initially the content of D and E be 20 and 1D respectively, and stack pointer is pointing the location 1000. Content of stack pointer is 5E. So up to 1000 the stack is occupied stack. So from 0 EFF onwards it is empty stack. So whenever this instruction is executed, content of top of the stack, that is 5E, is transferred into low order register. That is 5E is moved into E register. Then stack pointer is incremented by 1. Stack pointer become 1001. What is the data available in 1001? That is E2. E2 will now move into D register. Then stack pointer is again incremented by 1. Now the stack top indicate the location 1002, that is the content of stack pointer now. So up to 1002 the occupied stack. So from 1001 onwards it is empty stack. Pop instruction addressing mode is register indirect. It is a 1 byte instruction. Machine cycle required is 3, opcode fetch, memory read and memory read. Total T state required is 4 plus 3 plus 3, 10 T states. Here opcode fetch required only for T state.